Hey everybody, so today I want to talk to you about agents. It's been a long time since I've talked about it overall, and a lot has changed since the last time that I talked about it. I'm going to frame this video by giving you a few different research papers, 3 different research papers, and I'll give you 2 Colab notebooks as well by the end. And uh, overall, the major framing that I want to put around this particular video is that the significant change that has occurred within uh, agentic frameworks overall, like why you're hearing more and more about it, is because there's been changes with regards towards ability to scale, right? And then this is the thing that I try to highlight over and over again is the fact that scaling is not just scaling up, right? And scaling is like a problem and something that the IT industry has dealt with overall since the inception of the IT industry. Like that's kind of like the uh, waves and the ebbs and flows of IT overall. Like if you look at it from like a historical timeline perspective, it's all around getting over or different ways to scale, right? And then scaling up is, of course, the easiest way, right? Just add more parameters, add more GPU, add more CPU, add more processing power, add more RAM, whatever it is, right? But there's also different ways to scale outside of that, and then they're all generally speaking like mathematical equations, and that's the second part of this that I like. I want to boil down and distill within this, like, and it's like, to me overall, when you're diving into these things, like how do you actually like put these things into practical application, right? These 3 different research papers, for example, right? What's so how exactly do you distill this and process it overall in general? The very first thing is to understand that these research, every single one of these research papers or research papers overall, they present a framework and a methodology, and then they have experiments around that, and then they give their results and a conclusion. So every single research paper is going to be broken down into that context and framing, right? And then so within that, you also know that generally speaking, what they're going to give you is at the very least some sort of mathematical equations, so that which is their like methodology, right? Their theory that proves, and then they go through in their experiments, they put that into code. And then if they're good or they're nice, they give you the code, right? And then that's kind of like how all of these work out, right? This research paper here, I can just keep scrolling down, and then eventually we're going to hit math, right? And then here's theorems, and this one is a bunch of theorems, right? Theorem 2.1, 2.2, all just breaks down into calculus, right? But so the significant part of this research paper, and then why I start with this one, is so this one is called Learning Without Training, the Implicit Dynamics of In-Context Learning. And then if you see the date here, it's around like, oh, sorry, go back. The date on this research paper is July 21st, 2025. So that's like 4 months ago now, right? And that's kind of when you started to see and hear a lot more about agentic frameworks overall, right? And then so I'll just read the abstract here of this particular paper. So one of the most striking features of LLMs is their ability to learn in context. Namely, at inference time, an LLM is able to learn new patterns without any additional weight update when these patterns are presented in the form of examples in the prompt, even if these patterns were not seen during training. The mechanisms through which this can happen are still largely unknown. In this work, we show that stacking of a self-attention layer with an MLP or multilayer perceptron allows the transformer block to implicitly modify the weights of the MLP layer according to the context. We argue through theory and experimentation that this simple mechanism may be the reason why LLMs can learn in context and not only during training. Specifically, we show under mild simplifying assumptions how a transform block implicitly transforms a context into a low rank weight update of the MLP layer. So kind of summarizing and putting this into context overall, what they do is that it's this, right? Stacking of a self-attention layer with an MLP. And then so that self-attention layer is, we'll call it reflection. And then there's going to be like within, especially these 2 research papers here, they call it like reflection overall, and when they go into their frameworks, they utilize reflection, and then when they're talking about that, they're talking about this, right? And then this from this particular research paper here, from July 21st, 2025, right? And then so this is like the ability overall to do like this particular framework is new. It's like 4 months old, right? And then like this particular framework here and what this does unlocks and allows for a lot of things, new things within agentic frameworks and agentic learning overall, right? So I think like the next way to handle this is to go over to this next research paper, which is Agent Learning via Early Experience, put out by Meta Labs and The Ohio State University on October 13th, 2025. The first thing I want to note with this research paper overall, just calling it exactly how it is, like if I had put out this research paper, it was just me, like I would be criticized for this, right? Just putting like, because there's no code that they release within it. They do release their theorems and their math, which is how I'm able to reconstruct it. And then so I'll do better than Meta does in this instance, and I'll give you code for their framework, right? But so overall, what this model is, agent learning via early experience, is so they introduced this concept called, and they call it early experience, right? Which is interaction data generated by the agent's own actions where the resulting future states serve as supervision without reward signals. And then so this is essentially their framework within this research paper, right? And then so the reason why I start with this one, and I mentioned what exactly their framework is here, we show that stacking of self-attention layer with an MLP allows the transformer block to implicitly modify the weights of the MLP. Their framework, this framework couldn't exist without this as the precursor, right? So I'm just highlighting and pointing that, like if I'm going through this chain of processes, to me, it's this is the date here when you see like the big changes all around this, right? You see changes around this and leading up to that, before that, but like again, it all boils down to math and understanding math within this, right? So it's all of this and all of these frameworks are in the realm of reinforcement learning, right? And then so the first kind of major mathematical advancement around reinforcement learning when it comes to these agentic problems is the advent of PPO, or proximal policy optimization. And then PPO allows for RLVR, or reinforcement learning with verifiable rewards. And then so that's kind of a big thing that comes to the table here. And they bring forth this wonderful chart that's like talking about that is related very specifically to this, right? And then so what they've been RLVR requires reward, right? Is the bottom line within that, and then so and that's PPO, and then you have other frameworks that have kind of advanced from there, like GRPO. GRPO is like the biggest one, and then you have offshoots of GRPO, right? But the difference between PPO and GRPO, so PPO requires reward, whereas GRPO and methodologies around that are reward free, and then so that's just advancements in the mathematical equations, right? It's just like when you go down to the equations that the preliminaries that they put out here, right? So you're just putting more calculus into these things, right? And like the most like I think a lot of people struggle with this overall, right? And I want to highlight this and put this into as real world terms as I possibly can. So let's say that you want to build an agent and I want to build an agent, and then so we utilize the same backbone. Who cares? We'll both utilize ChatGPT, right? It doesn't matter to me. And then within that, then we are wrapping our algorithms around that, right? And then so you don't wrap any algorithms around it. You just you go just baseline ChatGPT, right? And then I take and I read this research paper, Agent Learning via Early Experience, and then I read through, I understand their framework and their methodology. They give me the math behind it, right? Okay, now I understand how the math works within this. I can take their preliminaries, and they do a decent enough job of giving me all of the math to reconstruct it, right? And then so I take that, and then I take ChatGPT, and then I wrap ChatGPT around this, right? Around their agentic self-learning framework. And then in this instance, they call it it's the full framework that they introduce in that particular research paper is implicit world modeling plus self-reflection. And then let's say that I use it with ChatGPT because that's what we're both doing it for, right? And then so I do that, and I do this, and then I wrap all of my ChatGPT around this. My performance of my agent is going to be, let's say, 30-40% at least more performant, better across the board than your agent, right? And then all I'm doing within this, and the difference between my model in this instance and then your model in that instance would be just the simple addition of these particular mathematical algorithms and frameworks that I'm building into my model that you aren't. And then it's literally no amount of money, time, effort, etc. makes up for that, right? It's understanding the mathematical frameworks and the methodology and those particular algorithms, and then why I would want to and how to use that particular algorithm in that particular situation to get the benefit, right? It's not like it's the advantage is all in understanding the math and breaking that down. Like, I can't state that enough, right? But then so diving deeper into and moving away from the math and into this particular research paper, there's a concept that I mentioned when I went over the code, right? Which is implicit world modeling, which is that's kind of like the whole framework of Meta overall. And then so Yann LeCun overall, his big criticism of LLMs from the beginning has been that they aren't world models, right? Like, if you listen to a lot of Yann LeCun's criticisms, that's exactly what he talks about, that they're not, that there's LLMs are distinct from this category here, world models. And then he Yann LeCun from the beginning has been a big fan of these models, which are essentially like models that learn from experience, whereas LLMs in their classical form are models that learn and predict off of tokens. So it's a difference of predicting off of a token versus predicting off of an environment, a world, right? And then, but what and this is Meta's paper, right? What has changed within that, and what is going more and more within that is that recent work extends this idea to language agents by using LLMs as world models, right? And then this is something that 3 years ago, Yann LeCun flat out said couldn't occur, and then so here we are, right? I'm not knocking Yann LeCun in any way. He's kind of one of my idols, but just pointing that out within this, that there's been a change and a shift in ideology around these things and understanding around these things, and 100%. This is Meta's on paper, right? Recent work extends this idea to language agents by using LLMs as world models. So there's no inherent barrier between and creating a implicit world model or IWM model, which is essentially that extends also to Yann LeCun's the JEPA models, etc. Right? You can build those things into and inside of and on top of the transformers architecture, and then so you can get those with LLM models. So there's nothing, there's no inherent barrier, there's no uniqueness within that, right? And then the next concept that they go into is that self-reflection concept, which is again given to by this, right? This is when they're talking about self-reflection overall, they're talking about this. And then so with this particular Meta research paper, the important thing to understand and highlight within this before I move on to the next paper is where they put this innovation is early on in the training process, right? So when you're training when you go through and you're training a big LM model from scratch, the process is still relatively the same as it's been for a while. So you do the very base layer is unchanged, right? And that's what I want to highlight, is that it's the first step. Step one is that you do a supervised fine-tuning process, right? And then that's just you take in like all of the data and just all the data, and then it learns on tokens. And then supervised fine tuning is like essentially like most of that training cycle, right? And then it's at the very end you splash in reinforcement learning, and then generally it's like RLVR, but it's like after that, like, so you do like a supervised fine tuning process and then unsupervised fine tuning process, and then at the very end splash in like RLVR, right? This is they call it early experience, where you're splashing in that RL, like in this instance it's RL, like not RLVR, because it doesn't require, it's a reward free for their particular framework, so not RLVR, but you do that like right after the first supervised fine tuning process. So it'd be like, training step 1, supervised fine tuning, and then training step 2, what they call this early experience, right? Which is just like it's reinforcement learning via their particular framework that they're laying out here. So the advancement that they're doing is that they're taking this advancement from Google in July and then applying it to the early portion of the training process overall. And then again, like just highlighting it, they don't give out the code for that, like in their research paper, that like they don't. Like, so here it is. I've reconstructed essentially their algorithm from the research paper there, and I'll give you a link to this collab notebook here. So if you want the actual like implementation of their framework, and then how it's working out and the implementation of that math, here you go. And then so moving to the next one here, which is EVO Test, Evolutionary Test-Time Learning for Self-Improving Agentic Systems. And this is put out by National University of Singapore as well as Microsoft Research. And then just highlighting it in contrast to the Meta paper, the code is available at their GitHub here, right? And then I'm like, just calling it like it is, and like, I mean, I didn't do it, but like, so Microsoft is at this point more open source and more releasing more with regards towards their papers overall than Meta is. Just pointing that out, right? Like a lot of people want to knock that overall, but like Microsoft is, to me, Microsoft is releasing more with their research papers to like the research community than anyone else overall, and that's been a trend, I'd say, the last like 6 months or so overall, and like I notice it, and so I'm just highlighting that and pointing that out. But so this particular research paper takes and is needs this concept as well, right? But rather than taking and doing that during training time, this is all about at test time. And then so this test time inference is like and test time training, test time optimization, etc., is also kind of it's a major contributor to the advancements of this new trajectory that you've seen with regards towards agentic frameworks, and then all of a sudden people are talking about it more and more overall, et cetera, right? It's because of these things and these types of advancements. And then so this particular paper was interesting and caught my eye because it's a test time training method, which means that so it's the model's already trained, already tuned, it's inference just like you normally would, but then you can also scale up the ability of the model to reason during like inference, right? And that's kind of a new advancement that we've found based off of this, and then because of this, and then so these methods, these test time scaling methods, they're computationally expensive and super hard to like they add like there's no way to make this like cheaper overall, which is like why I don't like the methods overall. Like, I mean, generally, to me, it's kind of cheating, but like, they perform super well when you implement this, and this isn't going to go away, right? And then a lot of the gains that you're seeing with regards towards agentic frameworks are all into this. So when it comes to like real world like implementation, whether or not I philosophically think like it's cheating or not, doesn't really matter, right? Like, it works in the real world, and it 100% increases agentic performance to a point where there's the main agent benchmark that exists overall is like at a scale from 0 to 100, but humans aren't 100 on the scale, right? Humans have error rates too. And then so humans generally, like a trained human, like a professional human would score like an 82 on the the test that is around these things, and then the current agents are getting into like 68s to like 68, 70 around there, right? And then so it's getting like closer and closer to that 82. It's like very close to that 82, right? And then so that's why, again, why you're seeing more and more discussion around these things, because these advancements have just been slowly pushing and chipping away and chipping up towards like, I mean, once it's at 82, like that's it. It's better than, it's level with professional human or better, and we're about 12 points off right now, and it's still like I don't know, like I hate to project with the speed of these things, but I think that's still another year or two, but we're there, right? and it's not like I don't see a roadblock. Like there's going to be, and there needs to be another one of these, right? Like, and something like this in order to push past. But there has been and will continue to be one of these, right? Before this, there were other advancements and like PPO and GRPO and et cetera, right? And then so there will continue to be something that will push this and allow for that scalability to get to, from we'll call it 70 to 82, and then but so diving into this particular framework here, what this particular framework does is they present and they produce a framework called EVO Test, and then so EVO Test has two roles: the actor agent, which plays the game, and the evolver agent, which analyzes the episode transcript to propose a revised configuration for the next run. And then this configuration rewrites the prompt, updates memory by logging effective state actions, tunes hyperparameters, and learns the tool use routines. On our JTTL benchmark, EvoTest consistently increases performance, outperforming not only reflection and memory-only baselines, but also more complex online fine-tuning methods. Notably, our method is the only one capable of winning 2 games, while all baselines fail to win any. And then so the significance of this, right, is that they refer to the reflection method, and that they're outperforming not only reflection and memory baselines, but also more complex, right? So they're directly referencing this method, and then saying that their framework is a enhancement, a deviation from that particular framework, which is true overall, right? They're taking that framework and they're building upon it, and then I would say that this is at this point something holistically different, which they call Jericho Test-Time Learning, or they're this is their benchmark for it, or JTTL. And then again, they give you all of the code for all of this, so you can feel free to explore their full Evo test on GitHub and run through it. But so essentially, their whole goal is to create a whole system evolution, right? A system that evolves within this, and then it wouldn't It's important to note that this doesn't fall, and still wouldn't fall under the definition of a self-evolving system, right? Because you're having to input this framework within it. But so the evolving and the system of evolution in this instance is 1, rewriting the guiding prompts to encode new strategies; 2, updating a structured deployment time memory with records of successful and failure actions; 3, tuning decision-making hyperparameters like temperature and expiration strength; and then 4, refining the tool use routines that govern how and when memory or Python code is accessed. And then so within this, these 4 steps here, right? These 4 steps that they highlight, this has been the crux of the major advancements that have occurred since July, right? Every single framework that you see, every agentic framework is these 4 steps, right? It's just different math behind the 4 steps, and it's super important to highlight that. But then it's important to note and highlight the difference that this provides and brings, right? Because so what this does is, and what this allows for, is for the model to train on its own experiences and then to use its own experiences as data, right? And that's still a hard concept that I struggle with when it comes to like companies and corporations around these things, right? It's like they like understanding that like the framework is to have the model evolve, right, and to learn from its successes and failures. And then so how you do that, like very simplistically and very specifically, is you're just setting up like an entire org and an entire framework, just like you would for like an actual employee, but then you're just giving all of that framework to the AI, right? And then so whatever like that, like whatever a human would be doing in that process. So if it's like a marketing process, you would be like, you want to give it like, here's campaigns, right? Like, and then you can't just say like build campaigns from zero, right? Like, because it needs some sort of starting data, like in order to have successes and failures. So then within that, it's a the only like these projects succeed or fail based off of the like ability for the team to transfer and willingness to transfer knowledge within that to the model, right? Is essentially what you're doing, because you're setting it up. Let's say like if it's a sales campaign, you're setting it up with sales scripts. You're training it. You would like generally have like a sales rep training it as a baseline, right? Giving it that baseline of here's exactly what its job should be, essentially set up by the person that is in charge of that job. And then that's the baseline that the model goes off of. And then once you have that set up, like that's your framework that you build for the model, then you're just measuring successes and failures, right? And then it's super simple past that. Like if you just understand and then just can get past that, it's a super simple process overall as to how it works, right? Then it's just all mathematics and optimizations. But then so diving deeper into this particular research paper and this particular methodology. This particular methodology is all about, they call it an evolve phase, right? But the thing I don't like, my one knock on this research paper is that like it's like the and it's not a knock, right? It's a interesting concept that they're putting evolution or evolving into this paper, but like and into this framework. But I think like in my kind of like hypothesis as I was going through and then reading this paper is that they could take it one step further, right, within this, and then with all of this known, and then so with all of this known and surrounding all of this now, etc., I wanted to experiment around that, and so I'm calling my experimentations around this Evo Swarm, based off of like, because I got the idea from their Evo test, right? So Evo Swarm is an evolutionary test time optimization for LLM agents, and then so Evo Swarm is a lightweight experimental framework that tests whether evolutionary and swarm algorithms can improve reasoning performance at inference time and not just during training. So it treats each episode as a microevolutionary arena where populations of prompt and hyperparameter genomes compete and adapt in real time. So I'm taking like a lot of their framework, right? Like this framework here. But then when I look at this framework and I'm looking at it and how they built it out, I'm like, okay, like why can't they just use particle swarm optimization and then genomic and genetic algorithms? And it's like, well, they can. And so like here it is, right? And then so in my best tests, like I'm able to the Evo Swarm is getting like increases success rate overall by 66%, and then increases average reward by 79%. But that's in my best test on this, right? The test, it takes a long time to run through on this. Like in this test, like it's more like I would call it, I don't know what 10% or so in like increase in performance, right? And then so it's a lot less significant overall. And then so I do want to highlight that like these benchmarks up here are from the best, but like that I got out of it. But then I haven't optimized this algorithm in any way. Built it. I just had the idea, right? I was like, okay, like this is interesting. It's they call like all built all around, like to me, like evolutionary algorithms, but then they don't utilize evolutionary algorithms within it. So I just wanted to see what would happen, like if you build out around this particular framework, right? So within this is the first implementation of this that I'm aware of swarm algorithms and genetic algorithms at test time inference, right? And so what this specifically does is exactly what this framework does, but it's utilizing genetic algorithms and particle swarm optimization in order to optimize and do the optimization process and go through the steps, right? And then so it is an RLVR process, as you can see, because it's utilizing rewards, right? If we have that reward there and I'm showing the results from the reward, that's how you know that it's an RLVR process, because I'm utilizing verifiable rewards, or else we wouldn't be able to get the average reward if the reward weren't verifiable, right? Evo Swarm demonstrates that even small compute-bound evolutionary populations can yield measurable reasoning gains at test time, hinting at a new frontier of adaptive self-optimizing inference. Like, just highlighting, like, this particular implementation and this particular algorithm is not something I've seen anyone do before overall. It works overall really cool, go math. And then so again, again at the end, highlighting all and going back to the beginning with all of this, that it all just boils down to math, right? Understanding, why do I go through these research papers every day? Why do I just gloss over them, etc., right? It's a matter of understanding and then adding another tool to my toolbox overall, right? And it's a mathematical tool. And then so when if I get a project that's, let's say, Agentic Frameworks, for example, right? I can very specifically go back and then reference these three particular research papers and then these three algorithms, and then maybe I want to use one of them for the project, or maybe I blend all three. It depends on the project overall, right? Let's say building out a marketing agent, it would be different than building out a knowledge base, etc., right? And then so depending on exactly what I wanted to build out, what the context is, I know and I have these in my tool belt for if that particular situation boils down to and is necessary for it. And then I can come back here. I have my algorithms and my math that I can refer back to. And then again, it's just all in the moment, building out the specific algorithm and equation for that specific problem, right? And then so if I understand it on that level, when I break it down, when I deal with that specific problem, when I frame it in these things, if I'm dealing with, say, for example, competition in that arena, if I'm doing it and going at it at this level, I'm 100% going to win, right? Because I'm essentially optimizing to the point where I'm getting maximal gains possible. Let's say that the baseline is, again, ChatGPT, and then if you wrap a simple algorithm around it, if you just do a Google search and you take that next step and you know a little bit what you're doing, let's say that you could get up to 30%. But then if I am able to fully optimize past that, I could get up to, let's say, 44% past ChatGPT, and then I win, right? And that's kind of how it all boils down to why I do these things, why I stay, my goal flat out honestly is to have and stay on top of these things. And if there's a new framework that comes out, something that is very new, that is significant overall, I like to and want to know about it that day and understand exactly how it works about it that day. So that's why I continue to do this overall, right? And then so if you like that, if you like this type of content, please like and subscribe. Thanks very much.